In this video, we continue talking about local behavior of a polynomial function, and here's a very important fact about this polynomial function. Actually, it's 2 in 1. Let's read it. It says a polynomial of degree n will have at most n x-intercepts and n-1 turning points. So again, like I said, 2 in 1. We're talking about x-intercepts. So the maximum number of x-intercepts is n, same as the highest degree of the polynomial. But it doesn't have to be exactly n. It says at most. Just like in the example that we saw in the previous video, it was a 4th degree polynomial, and we did find 4 roots of the associated equation, but only 2 of them were real roots, which translated into x-intercepts. So in other words, the number of intercepts does not necessarily equal to the degree of the polynomial, but this is the maximum that it could ever be. Okay, now as to the turning points, it's at most n-1. So it's 1 less than the degree, again, at most. So let's take a look at this example. It says, without graphing the function, determine the local behavior of the function by finding the maximum number of x-intercepts and turning points. So here, maximum number of x-intercepts is 10 because the degree of this polynomial is 10. Intercepts is 10. And the maximum number of turning points is 1 less. It's going to be 9. Okay, could be less, number of intercepts could be less than 10, but 10 is the most that it could have, and same goes for the turning points. It doesn't have to have 9, all 9, but 9 is the most turning points that it could have. Now it's your turn to try. What is the maximum number of x-intercepts and the turning points for this function? And I'm going to read it to you. It's f of x equals 108 minus 13x to power 9 minus 8x to power 4 plus 12x to power 12 plus 2x cubed. Pause here if you have to, and we're going to continue. So here, it's backwards. So we're given a graph, and we need to basically figure out how many intercepts, how many, okay, let me read it. It says, what can we conclude about the polynomial represented by the graph shown based on its intercepts and turning points? Okay, so the number of intercepts is 2. All right. By the way, by looking at the shape at the end behavior of this graph, can you tell if the leading term will be even powered or odd powered? And I hope that you said even powered. Okay, so it has 2 x-intercepts. right? Which tells us that the degree of this, at least 2, of the polynomial is at least 2. These 3 dots means therefore in math. The degree of the polynomial, and they used n to indicate degree n, is at least 2, so it must be greater or equal to 2. Okay, so what about the turning points? We have 1, 2, 3 turning points. So 3 turning points. Which means that the degree of the polynomial is actually greater than 3, because remember, for the turning points, it's at most 1 less than the degree of the polynomial. So it must be greater than 3. So it cannot be 2 then. It could be 4 or more. So we conclude that the graph represents a function, a polynomial function of degree 4, of even degree of 4 or higher. Okay, so there we go. And we also concluded that degree is even, right? So even. All right, so now I would like you to try figure out this equation or function, same objective. We have a graph. What is the possible degree of this polynomial function? And again, pause here if you have to, and we are going to continue. This is the last type of example in this video. This is given the function f of x is negative 4x, and then x plus times x plus 3 times x minus 4. Determine the local behavior. Okay, so what can we say about this function? Well, fortunately, it's already factored, and we see that this function will have 3 real, if we plug in y equals 0, so we're going to have 0 equals negative 4x times x plus 3 quantity times x minus 4 quantity. So this equation will have 3 real solutions. Okay, has 3 real solutions. Therefore, we have 3 X-intercepts. And those are, so this term, because we have actually 3 terms here that could turn into 0, right? When do they turn to 0? The first one turns to 0 when x equals 0. So the first intercept is 0, 0. And then the second turns into 0 when x is negative 3. So we have a negative 3, 0. And the last one turns into 0 when x equals 4. So we have 4, 0. So those are our X-intercepts. What about the Y-intercepts? Y-intercept. Well, we could, to find the Y-intercept, we set x equals 0, and f of 0 is 4 times 0. Actually, it's negative 4. And then we have, and this is 0, right? So then we have 0 plus 3, 0 minus 4, which does not matter because it all is multiplied by 0, is going to give us 0. And we already have that point right here. This is our x-intercept and the y-intercept at the same time. And remember, the polynomial function can only have one y-intercept. So once we had it here, we already knew that's what it would be. Okay, so what else can we tell about the behavior of this function is turning points. So because it has three factors, and in each factor x is to the first degree, that the degree of this polynomial is 3. So n equals 3. That's our highest degree, okay? And because of that, it will have at most 2 turning points. So the graph of this function has at most 2, so it's 1 less than the degree turning points. Okay. So, and I do have one problem that I would like you to try, and it's f of x equals 0.2 multiplied by the quantity x minus 2 multiplied by the quantity x plus 1 multiplied by the quantity x minus 5. Determine the local behavior, x-intercept, y-intercepts, and turning points, the number of turning points. All right, guys, and I'll see you in the next video.